Okay, good morning. So let us continue the lesson on algebraic identities. Yesterday we learned about the squaring rule, which reads in this way. I have a binomial, means that I have the sum of two terms, or even if there are more terms, you can view it as the sum of two expressions, yes? And then the goal is to square it. So I told you that it is better to understand and read it in your own language. So it becomes the first one squared plus 2 times the first one times the second one. Of course, you really don't need to put these dots. And then plus the second one squared. Of course, in the book might be you see another formula, but I try to motivate to convince you that both of them more or less are the same thing. Yes. So if you want, you can have it in this form as well, but it is not essential. Today we want to learn another one. Again, the reason that we study this another one is because this is ubiquitous in mathematics and appears a lot of places. So we just do it once for all and remember it. So another identity that we want to talk, this was a squaring rule. And now we want to talk about conjugate rule. So when conjugate rule matters, this is important. If I have two numbers or whatever, added once, subtracted once, and then you want to multiply them. Okay, this is very simple, but it appears a lot in a lot of places in mathematics. So people call it, they have given it a name so that we can easily refer to it if we need to. But you need to understand when it becomes important. If I have two expressions, once added, once subtracted, and I want to multiply the results, the sum and the difference. The answer is very simple. What you need to do, you need to square the first one, you need to square the second one, and subtract. So that is called the conjugate rule. Yes, if I have, of course, when this is an identity, if I want to start, the best starting point is to show why this is indeed true. And I think you can immediately tell me what to do. If I want to prove an identity, there is a standard way to do that. Start from one side, manipulate it, and reach to the other side. Yes? So for example, here I will start from the left-hand side. And what I can do, I can multiply them term by term. A times A is A squared, A times minus B is minus AB, positive B times A is positive BA, and then finally B times minus B is minus B squared. These two terms are not only similar but opposite, so they are totally cancelled, and I will get A squared minus B squared. Okay? So make sure that you understand that this 2 is not affecting the sign. So the answer to the conjugate rule always contains a negative sign in the middle. So don't get confused that because I have power of 2, I should make it positive. No, because power of 2 is not acting on the negative sign, it's acting only on B. And this proof shows that. You see, when I multiply B by minus B, automatically I get minus B squared. So this minus is always there. Okay? Okay, so that's the proof. For example, if I give you 2x plus y and then times 2x minus y. Again, let me emphasize again. If in the exam I ask you to use identities to simplify them, if you just multiply them, of course you will get the correct answer 100%, but that is not acceptable for that problem. And I recommended you even last day that even if you can multiply it, that is not for grades or something, try to learn to get used to using rules as much as possible rather than starting everything from scratch every time. Yes? So, the thing that I want you to understand, is conjugate rule applicable for this? The answer is yes. Why? Because I have two expressions involved. One of them is called 2x, the other one is called y. Once these are added, once the same are subtracted, and I want to calculate the product. Whenever this occurs, it means that the conjugate rule becomes relevant. Okay? And then how should I calculate this? Very, very simple. I have it in my memory, hopefully. Otherwise, you can have it in the formula sheet. Then the answer becomes the first one squared. But what is the first one? The name of the first one is 2x. So this becomes 2x squared. Always and always negative sign here. The second one is called y squared. But you shouldn't leave it like this. Of course, today's lesson is finished here. But there is a pair of brackets left. You have to remove it. But this one is not a squaring rule. Don't get confused because that's a product. And then I know that what do I have to do with products? It becomes the first one squared times the second one squared minus y squared. So that is the end of this problem. Any questions? And by the way, it doesn't matter. Some books might write it in this way. I hope that you agree with me. The answers are the same, yes? If you have two expressions subtracted and then added and you want to multiply, the answer to this and the answer to this would be the same. So it doesn't matter. Some books write the positive first, negative second. The other books write the other way around. But what is important is the first and the second. Okay? So let me ask you one question. What do you answer to this? If I write 3x plus 5y, and then I write 5y minus 3x. First of all, tell me, do you think it's a conjugate rule or not? Yes or no? Yes. It is a conjugate rule, but you have to be a little bit careful. Because I have two expressions involved. One of them is called 3x, the other one 5y. Once they are added, once they are subtracted. But if I want to write, be careful, I have seen students make this mistake. If I want to write the answer is the first one squared. This is a little bit sloppy language here. Because which one is the first one? So here, a plus b and b plus a is not, so this addition is not sensitive to the order. So when you want to see which one is really the first, you need to look at the term with negative sign in the middle. That is, so in this one, A comes first, so I say that the first one is A. Here I cannot say A is first or B is first, because there is no difference between A plus B and B plus A. So, it is not sensitive, this term is not sensitive to order, but this is sensitive. So here, look, if I ask you, is it a conjugate pattern? I hope that you agree with me, this is indeed a conjugate pattern because the terms involved are 3x and 5y, once added, once subtracted. And then I want to multiply them. So it means it's a conjugate rule. But which one is the first one? If you just carelessly say 3x is the first one, that is wrong, because I told you that's not sensitive to the order. But you need to go to the one here. Which one is the first one? The one coming first in the negative one. So this becomes 5y squared minus, always minus 3x squared. And then you have to remove the left brackets. So this becomes 25y squared minus 9x squared. Yes? So that is the answer. Any questions? Okay, so that is the more or less the lesson. But we want to practice a little bit more now. Okay, so let us, for example, ask you this. X over 2 plus y over 3 multiplied by x over 2 minus y over 3. Do you feel the conjugate pattern? So you should train your eyes so that you can immediately catch the pattern. So that's a conjugate pattern, yes? Two terms are added, the same two terms are subtracted, and I am interested in multiplying them. So, which one is the first one? I look in the pair of brackets with negative sign. This is the first one. So this becomes the first one squared, always and always negative, the second one squared. But you shouldn't stop here because there are pairs of brackets left you have to remove them. So this is an old lesson. A fraction to power 2 becomes the numerator is squared, the denominator is squared. The same thing happens here. Y squared 9. Again, let me remind you again, don't think that this becomes positive because of this power 2, because as you see, 2 is only acting on the fraction itself, regardless of the sign between. So that's the answer. Yes? Okay, but let me make it a little bit more interesting. For example, do you think this is also a conjugate pattern? Let us see if this also... Apparently, this is not exactly matchable with what we have, but we might be, if by practice we can understand that this is indeed also a conjugate pattern, but you need to engineer it a little bit so that it fits to the pattern. So how should I engineer that? Because first of all, there are 3 terms involved in each pairs of brackets. In the original pattern, I have 2 terms, 2 terms. So you need to think, we have this experience from the previous lesson. Every 3 terms can be viewed as 2 terms, yes? One, for example, if I say how many terms are involved here, of course in principle it is 3, but you can view it in this way if you want to. Then I can say that is one collection of expressions and this one. So any sum of 3 terms can be viewed as the sum of 2 terms as well. Okay, so let us just do that. Let me change my color. So that's the problem. Again, if I give you this and you really are not interested in learning these, you can start multiplying term by term. 3 terms, it becomes 9 terms. Okay, that's up to you. I really want you to avoid that, even if you are free to use. Try to use the identities as much as possible, okay? Otherwise, if you don't pay attention to that, you will not learn. So what I do, I will, in my head, I write it in this way. I hope that every one of you agrees that there is no difference between this and this way of writing. You might say, Babak, why are you bringing in extra pairs of brackets? You are making things complicated, but you will see why. Because, now tell me what can I do here? I can take a minus sign out between these 2 terms, and what I can write is b plus c. And now hopefully you agree with me, the conjugate pattern appears, emerges, yes? Why is that? If I ask you how many terms are involved, I can say 2. The name of the first one is A. The name of the second one is B plus C. You see, A and B plus C are the expressions involved. Once added, once subtracted, and then I want to multiply them. So that's exactly the pattern, yes? So what is the answer to this? The answer becomes the first one to power 2, minus and minus, always, the second one to power 2. Okay, I want to wait a little bit here. Is there something that you don't understand up to this point? Is that clear or not? Okay, so, but the problem is not finished. Why? Because you see that there is still a pair of brackets left. Okay, I have to continue. So, but now, it means that I have to get rid of these pairs of brackets, but this is the previous lesson. Yes, because I have the sum of 2 terms, and I want to square it. So this becomes the previous lesson. So this means that I have to write a squared minus, let me put the pair of brackets, but then, according to the lesson yesterday, I can expand that. It becomes the first one squared, 2 times the first one times the second one, and the second one squared. So this was one problem, but if you look at it closer, you have to use both patterns. Conjugate first, and then after that the square root. But it's still not finished, because I have a pair of brackets left. I have to remove it. I hope that you not so careless. This minus sign is not only for the first one. This is a very common mistake by students. This minus sign behind the pairs of brackets is for all of them. So this becomes a squared minus multiplied here minus b squared minus times positive minus 2bc and then minus c squared. That is the answer that you need to provide for this problem. Yes? Is that clear? Okay, so let me make it a little bit more complex. I don't know, do you think you have problems with these simple ones? Simple ones are actually two terms, you can immediately see that and square them, subtract. Yes? Yeah. There are many of those questions in the book you can practice yourself. After nearly 45 minutes, I will give you time to practice. But let me try to make it a little bit harder. So for example, let me involve 4 terms this time. So for example, let me write 2a plus, let me write 2a minus b plus 3c and minus d. Yes? And I want to multiply this by, so let me make this one also negative to make it a little bit more involved. So then I will make this one 2a plus b plus 3c minus d. Okay, so let me see if I have done it right. Yeah, good. So assume that we want to expand this. This is not probably as trivial as these simple examples. This, first of all, 4 terms are involved. What? How should I get suspicious about that there is something about conjugate pattern here? Because at least you see the terms involved are the same. 2a, 2a, b, b, 3c, 3c, d, d. Yes? So then, of course, then you have to engineer it. Because if you want to use the conjugate pattern, it should be like this. It should be something in the box, I don't know, minus something in the circle, and multiplied by this, yes? If you have this kind of thing, regardless of what are inside these two, forget about it. If you can detect this pattern, then that's a conjugate pattern. So the answer becomes that, yes? So you need to match, train yourself so that you can immediately match this one, if possible. Sometimes it is not, with this pattern. So you need to give a role to this box in this problem. You need to give a role to this circle so that the whole expression becomes like this. If it is possible, then I can use the conjugate pattern. Okay, can you tell me how should I engineer this now? In any ways, if I want to use the conjugate rule, I have to have 2 terms involved somehow. The same 2 terms here. How should I collect them to engineer them so that it works, if it is possible? Yes, Ali?
Put brackets around 2a and minus b and 3c minus d, and same thing with the other brackets.
I don't think it works. Let us check, because that is also a common mistake. So what Ali says then is to put a pair of brackets around these two. Yes?
Wait, minus 3c is in the bracket.
Okay, minus 3c like this. Okay. And then minus the outside. This is what you mean.
Yes.
Okay, so if that's the case, if that is the case, it's inevitable. The next one should be this, yes?
Yes.
Otherwise, it is not possible. Because if you want to have a conjugate pattern, yes, this is a conjugate pattern. And this one is equal to this one. But unfortunately, this one is not equal to that one. Yes? So this engineering is not working. It's not understandable, but this is good because it's very good that you say these things, because if you make a mistake, you can take lessons from your mistakes. First of all, if you are a teacher, can you explain to Ali that why this is not working, yes? Is that clear? Because first of all, Ali didn't make any mistakes here, because this is exactly equal to this. Good. But if I want the next one to make a conjugate pattern with this one, this should be the same expressions, yes, but with positive in between. If that is the case, yes, this is a conjugate pattern. but you see 2a is 2a minus b is not equal to b. So this term is not equal to that term. So this is not working. Any other suggestions so that it works? Any suggestions? Yes, try it. Yes.
I'm not sure if this is right. But
Yes.
my theory was 2a minus b minus brackets 3c plus d, and then the other side is 2a plus b plus 3c.
It doesn't work, but that's also good to say. Let me just write what you said. You said what? Take 2a with what?
Minus b.
Minus b together, what you mean, okay?
Yeah.
And then,
And then minus.
what you said, if I remember, you said something like this. So that is, again, not wrong till now, yes? Because 2a is 2a, minus b is minus b, minus sign multiplied inside makes this one negative, which it is, makes the second one negative, which it is. So that's completely right. If you write this blue one instead of this black one, I have to agree with it. Okay, and then can you engineer the second one as well? Because, I mean, I want you to understand, if it is going to be a conjugate pattern, the second one should be this plus this. Yes? 2a minus b plus 3c plus d. But is it the case? 2a positive, so far so good. But minus b, positive. So, if you, this one is not wrong, but the second one should be this, otherwise they cannot make the conjugate pattern. And we see that this is not the case. So this is not working. Any other suggestions? Understand that this is not working? Yes? Okay. So, any other suggestions? Yes, Rasmus?
Can you say that the first part is 2a minus d?
Let's just wait. 2a minus d in pairs of brackets or no?
Yeah, in a bracket.
Yes?
And then the second part is b plus 3c. So we have negative.
Like this you mean?
Yeah.
Okay. So first of all, let us see, is this correct or not? Rasmus is proposing this one instead of this one. First of all, this should be exactly equal to this. I am not allowed to change something. So this pair of brackets I can safely remove. It becomes 2a, minus d, that's right. But this minus sign will go in. It becomes minus b, that's right. Minus c, minus 3c, minus 3c. So, okay. And I want to see what happens for the next one. For the next one, if it is going to work, and if it is going to be a conjugate pattern, the next one should be like this, yes? It's still a question mark. But is it true or false?
True.
Yes, because 2a is positive, minus d, b, and 3c, 3c. So that is a nice engineering, yes? Now you see, first of all, am I allowed to put equality? Yes. Because this part is equal to that part, this part is equal to that part. What is the benefit of doing something like that? Then you immediately realize you can give the roll of the box to this one, the box here, the roll of the box to 2a minus d, and the roll of the circle to this. If you do not look inside, you immediately see that this pattern emerges. Okay, so that is exactly the conjugate pattern. So, okay, what is the answer now? The answer is the first one squared. Which one is the first one? I need to go to the pairs of brackets with negative and look which one is the first one. So the first one is 2a minus d squared minus always the second one squared. This is today's lesson. Is that understandable so far? So sometimes it is hard to a little bit engineer it properly, but you know the goal. You need to do some trial and error to understand that. And if you practice, you will be more skillful and you can immediately detect the pattern. But the problem is not still finished because I have two pairs of brackets left. But they are not today's lesson. This one is the previous lesson. This one is also the previous lesson. These are squaring rules. Yes? So what should I do? you have to do it patiently. So I put a pair of brackets for the first one, negative, a pair of brackets for the second. But can you help me to do that? You need to remember the formula. The first one squared. Can you do it in your head? 2a squared. What's the answer?
4a.
4a squared. Let us do it in our head. 2 times the first one, which is 4a, multiplied by the second one, which is negative d, which becomes minus 4ad. And then the second one squared minus d squared becomes positive d squared. I want to wait. Is that understandable that I am using this rule, the squaring rule? I'm using the second version if you like to. This becomes this. And then this one is also a squaring rule. The first one squared is b squared. 2 times the first one times the second one. What's the answer, everyone? 6bc, thank you. And the second one squared is 9c squared. Yes? The problem is not finished. Pairs of brackets left. I have to remove them. For removing this, I really don't need to be careful at all because there is nothing behind it. I just remove it. So it becomes 4a squared minus 4ad plus d squared. And then I remove this, but I have to be careful. This minus sign is not only for the first one, but for all the terms involved. This becomes minus b squared minus 6bc and then minus 9c squared. But here you have to be careful. Might be there are some similar terms involved. If it is, you have to simplify them. But as you see, this is the end of the problem. Yes? So that is the problem. Any questions here? So these are a little bit harder questions. So you have to engineer it so that you make the conjugate rule to reveal. But sometimes it is very transparent and you can immediately start using it. Yes? For example, what about this number? Can you calculate this number easily for me now? So for example, I want to multiply, multiply 98 by 102. So can I use somehow today's lesson? Of course, this is not a primary school student can do that, but can you somehow find the relation between this product and the conjugate rule? Yes? Yeah?
You could do 100 plus 2 times 100
minus 2, exactly. That one is easier for our brain to calculate, yes? First of all, instead of 98, I can write a lot of combinations, but if you understand what is going on, hopefully you agree with me here that this is the best choice, because 102 can also be written as 100 plus 2. Now you see, do you detect the conjugate rule here? Yes, 2 numbers involved, once subtracted, once added, and then I am interested in multiplying. So this becomes the first one squared minus the second one squared. The first one squared becomes 10,000 minus 4. And this is very easy, 9,996. So I hope that you agree that this is, I wrote it a lot, but in your head you can really do that. Might be it is hard to do it in your head, but it was easy to do it in this one. Yes? That's also one possibility. One of the reasons that this conjugate rule is very important for us, because we have sometimes fractions whose denominator are involved with surds, square roots. For example, I would have 1 over square root of 2 minus square root of 3. Okay? And then I want to add this fraction by another fraction, for example, 2 square root of 5 minus 2. For example, I give you this and I ask you to simplify this expression. How do you think about the problem? Can I hear from you first? Because that is not a very subtle problem. I have a number written in a little bit fancy way, in exact form, because I want exact value. Of course, you can put these numbers in the calculator, get approximate values, but no. I want to find the exact value for this sum. So I want to hear from you. What is your suggestion? Because in principle that's not a hard problem. You know, if I ask you 1 over, I don't know, 2 plus 2 over 5, this is definitely simple for you. Where do you start from if I give you just that one? Because the only difference between that problem and this problem is techniques, is practicalities, you know? The ideas are the same. If you want to solve this one, you have to make the common denominator. But the common denominator between 2 and 5 is a friendly number, that is 10. But the common denominator between these two is a little bit nasty number, yes? You need to multiply this by that. This will work, of course. If I want to do that, this becomes the square root of 2 minus the square root of 3, square root of 5 minus 2, yes? And then I say this one, so you see, let me just do it here. You write it 10, 2 times 5. 10 divided by 5, 5 times. 5 multiplied here, it becomes 5. 10 divided by 5 2 times. 2 times that is 4. And then you add them, it becomes 9 over 10. As simple as that. I am using the same thing, but because these numbers are a little bit... I have to start working with the third signs, which is harder than working with these natural numbers. Yes, but the idea is the same. So you divide this in your head by that one, it becomes this number. And you multiply that number here, it becomes that number. Plus, you divide this number in your head by that, it becomes this number, and then you multiply it by 2. Yes? And then let us see what happens. It becomes the square root of 5 minus 2, and then I multiply 2 in. And then I get a mess. Yes? That is not wrong. If you write this, that's 100% correct. And that's exact value, by the way. But I cannot simplify more than that. Just I have to leave it like this. Yes? But one way, I want you to learn this trick. Because that is also ubiquitous in mathematics. In many places you will see this trick. Whenever square root signs are involved in the denominator like that, you can use the conjugate rule to get rid of third signs in the denominator. Okay? The reason that this is a little bit more involved is because in the denominators I have these square root signs. If the denominators are natural numbers, it is not hard. For example, if I give you a square root of 2 minus 3 divided by 5, and then I will give you, I don't know, square root of 3 minus 2 divided by 2. This is easier than that one. Yes? You take the common denominator to be 10. 10 divided by 5 2 times, you multiply it there. And then 10 divided by 2 5 times, you multiply it here. Yes? And then the point is that the denominator remains 10. You can multiply that. So it's 2 square root of 2 minus 6 plus 5 square root of 3 minus 10. And even minus 10 and minus 6 can be combined. So you can write it like this. Something like that. So what I'm saying is that if the denominators does not contain the third sign, actually adding them up or subtracting them is a little bit easier. Okay? Now, what I want to teach you here, I want to teach you how to use the conjugate rule to get rid of the square root signs in the denominator. Of course, you cannot make the square root signs go away forever, always. But you can get rid of them in the denominator, and the price that you pay is probably you get square root signs in the numerator. Yes? Having a square root signs in the numerator in general is easier to manipulate. Yes? That's the goal. Don't think that I will make a magic to just get rid of the square root signs. No, but it might be easier. Okay, so what I do, I will take this one. Okay, this might be a little bit strange in the beginning, but you get used to it, it becomes very easy. What I do, I rescale it. You know that if I multiply the numerator and the denominator simultaneously by a fixed number, I will not change the value. For example, I can multiply the numerator by 5, I multiply the denominator also by 5, it becomes the same fraction. But now it is interesting to know what I do. I do not rescale it by 5. I rescale it with a strange number. The number is the number which makes a conjugate pattern with this one. So it means that I put the square root of 2 plus the square root of 3 here, and I have to divide by that. Okay? So you see, first of all, what is this number? It's 1. And I am multiplying this by 1, so I'm allowed to put equality. Because but this is a little bit fancy way of writing 1. What is the philosophy behind that? The philosophy is that what happens, I multiply 1 by that, it becomes the square root of 2 plus the square root of 3. But when I multiply this by that, I intentionally wrote it in a way to make the conjugate pattern appears. And then the answer becomes what? Can you help me?
2 minus
2 minus 3, because this becomes the first one squared minus the second one squared. And then what happens if I continue? The numerator becomes this. The denominator 2, because the square root of 2 to the power 2 is 2, minus square root of 3 to the power 2 is 3.
But Baba,
Yes?
instead of writing square root of 2 plus square root of 3, instead of writing that, writing minus sign between them, does that work?
No. Because if you think in this way, because if I write minus 1 minus here, this becomes this multiplied by itself. Do you agree?
Yes.
Then this becomes this one to power 2. And I hope that you agree this is not equal to this one to power 2, this one to power 2. By the way, if I insist to expand this, what is the answer? This is a squaring rule now. This becomes the first one squared, which is 2. 2 times the first one times the second one. Square root of 2 times this is 6. And then this one to power 2. So, yes, you got rid of a square root signs here and there, but still another square root sign survives. So a squaring pattern is not a good one if you want to get rid of all surds. You see? That conjugate rule is good one. And now this becomes this one. And then the answer is what? Square root of 2 plus the square root of 3. 2 minus 3 is minus 1. And instead of having minus 1 in the denominator, I prefer to write it like this. But I also prefer to remove the pair of brackets. It's very interesting, by the way. This is a fraction. By doing this conjugate rule pattern here, you get rid of the fraction totally. It's not a fraction. So this number and that number are equal. Exactly. The point is that the original number contains a denominator, but the new number here, that was a coincidence. Usually the denominator will be there somehow. But this one is much easier. Okay, let me just do the next one as well. Let me ask you the question. What do you think I will do for the next one? I rewrite it and multiply it by what? Multiplied by something that makes a conjugate pattern with the denominator. What is that?
Square root of 5.
5 plus 2. I have to divide by that one as well. And then in the denominator, I multiply the numerator. It becomes 2 square root of 5 plus 2 times 2 is 4. But what is the answer to the denominator?
5.
5 minus the first one squared minus the second one squared 4. But 5 minus 4 is also 1. And I don't need to write it. So the answer to this is also without fractions at all. So this one is also something without fractions. And then the question mark is the sum of these two. I have the first one equals to that. And the second one equals to that. And I hope that you agree with me, this answer for our brain is much more manageable than this answer. And if you want to check, put this number in this form minus that number in your calculator or GeoGebra and press the enter button, you would get 0. So this means that these two numbers are exactly the same, but I hope that you agree with me, this is better to work with than the previous one, because it doesn't have any denominators, for example. So this trick sometimes I will use. In Math 3C, in the notion of limits and derivatives, we have to learn this trick. Okay? And so we can come to that later. Any questions? So sometimes in the math literature they say rationalize the denominator. So it means that write an expression equal to that so that its denominator is a rational number without square root signs. Yes? That is sometimes you see. So this is the new lesson. I hope that you learned that. You need to practice a little bit so that you improve your skills. I haven't seen such a problem in the book, but there are, by the way, there are nice problems in the book. I really want you to pay attention to the details and solve them. Okay, I will stop here, and in a moment I will actually update the Google Classroom so that you can start work. In the meanwhile, you can have a break for 5 minutes and then start. Thank you. Any questions, people at home? No, thank you.